Hello, this is Derek. This is part 2 of 5.2. And so in this half, we're going to look at, I think it's quadratic formula, solving quadratics by graphing, and then a little bit of formula solving. And so then just to remind you, quadratic formula, you've hopefully seen this at some point in your life. So if we have something of the form of a quadratic, and remember the ax squared plus bx plus c, the a, b, and the c are the coefficients. If we solve this thing around for x and got x by itself by completing the square, what we get is the quadratic formula here. So for this one, we're supposed to, let's see, the following equation has 3 solutions. Look for the greatest common factor, then use the quadratic formula to find all the solutions. Okay, so we have this equation here, and there's a common x. So let me get that factored out. And so this x out front means we have a solution of x equals 0. So here where it says the real solution a is that 0. And then what they're kind of tipping off here is that we're going to throw this in the quadratic formula, like it said, and that we can plan on getting some imaginary solutions for that. So let me show you how that will work. So in this case, a is 2, b is 7, and c is 8. And remember, the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So there's my a, my b, and my c. That's going in here. So x equals negative 7 plus or minus 7 squared minus 4 times a times c all over 2a. And we're cleaning this up a little bit. We're going to have negative 7 plus or minus 49 minus 8 times 8 would be 64 over 4. And then that's going to go negative 7 plus or minus, this is going to come out negative 15, so I'm going to write that as I, and then root 15, just to save myself a little space in writing, over 4. And then the way that you would put this in this answer box is this would be a negative 7 right there. Since there's nothing in front of the I, remember that's that invisible 1. So there'll be a 1 there, root 15, and then 4 down below is how you would type that. Okay, this one is also solved by quadratic formula, so I will move this over. So in general form, so we got a is 4, b is a negative this time, which is nice to see what happens, and then c is 1. So again, we're just going to toss in the quadratic. So x equals negative of negative 6, so that will be a positive 6, plus or minus negative 6. Right there's the spot to be careful. It's quantity squared, so that's always going to be positive. Sometimes I think people type it in the calculator without those parentheses, and then it comes up wrong. So b squared and then minus 4, and then a is 4, and c, and then all over 2a. So x equals 6 plus or minus 36 minus 16 over 8, which would be 6 plus or minus root 20 over 8. So then that 20, that's got a 4 hiding in there, right? So we can think of that as a 4 times a 5. So I'm going to sneak down here, and we'll go 6 plus or minus. So if I think square root of 4, that brings out a 2, and then the 5 stays inside, and then over 8. And then if you notice, right here, everything is divisible by 2, each term. The root doesn't have to be, but the number in front does, because if I thought of dividing by 2, I'd be able to cancel. So I'm going to knock a 2 out of everything. It's the same idea as factoring and canceling. It's just easier, I think. So this becomes 3 plus or minus 2 over 2 would be like a 1, so just root 5 over 4. And then here's the super trickiness. To get this into the computer, this is 2 distinct solutions. I wish they gave you an answer box. They don't. They'll give you one big box like this, and then you'll be like, what do I do? Here's what you do. You go 3 minus root 5 over 4, comma, 3 plus root 5 over 4. And I strongly suggest you click on the yellow arrow and use the fraction template to type these. It'll be so much easier. Than you can use the little square root thing as well. If not, definitely preview so that you make sure you have things typed right. Okay, so in the next section we'll get into graphing proper. But here we're just going to be given a graph and then asked to solve by graphing, which is actually really refreshing after the last few sections that we just did. So here we're given the graph of x squared minus 2x minus 8, so that's this. Use the graph to solve the equation f of x equals -5. So remember, f of x, that's like y equals -5, and y equals -5 is just a horizontal line through 5. So if I wanted to solve the equation x squared minus 2x minus 8, pardon, equals -5, like I could bring this over, -3 equals 0. I get factor like we've been doing, x, so multiplies to -3, adds to -2, so -3 and +1. I should get x equals 3, x equals -1. And looking at where I just drew this line through -5, right? If you look at where it's intersecting, there's -1 and there's 3. So -1 and 3, that is where this function equals -5. So we could do it with algebra like I did over here, or from the picture, if we're just looking, where does this equal 0? The zeros are at -2 and 4. So graph can give us that information as well. Okay, and then the last topic in this never-ending section of quadratics is solving formulas that are quadratic in form. And we do this a lot in physics, which was my major. Like, you're constantly solving formulas around. So for this first one, we are supposed to solve this for x. So let me write this a little bit bigger to start. And I'm gonna use a few steps just to show a couple of steps. I'm gonna get rid of this fraction first because fractions often disturb people. So I am just gonna multiply both sides by 2, because then half of 2, those would just cancel each other. So now I have 2u equals kx squared. Now I'm gonna divide out, I'm trying to get x by itself, so I'm gonna divide k since it's multiplying. And I could have here I could have multiplied by 2k on both sides and done that in one step. Please feel free to do so, as it gets sometimes clearer if I use a couple of steps. So now I think I prefer my x squared on this side, so I'm just going to rewrite the order because it will look nicer to me. And so now I have something squared. Well, the way that we undo the something squared is with a root. So I root both sides, but I remember that when I do that, I need that plus or minus. So this is going to be x equals plus or minus the root of 2u over k. And so that would be this solved for x. This next one, again, let me write it a little bit larger. So here we are solving this for the a. This time I am going to do it in one step because I think it's cleaner. So notice I have a 2 and a c. They're both multiplying. I could have the c next to the 2 if I wanted. So I'm going to just do that. Because now these cancel, my c's cancel, and that gets me closer to that a by itself. So now I have v over 2c equals a squared plus b squared. And now I'm going to subtract the b squared over. And I think I'm going to rewrite it. So now it's going to be a squared equals v and then over 2c, and I'm subtracting that b over. So that's going to be minus b squared. And then again, I'm going to need to use a root to undo that square. So let's do this, plus or minus, and then that would be it. That would be the answer. You may have some temptation to try to take a root there, and that's not a good temptation. And the reason is, if you think about having, say, the square root of 25 minus 9, you don't go square root 5 minus square root 3, right? You have to go 25 minus 9, get 16, square root makes 4. So you can't root the individual pieces across that minus. You'd have to do that operation first. So that would be it. Okay, for this last one, use the quadratic formula to solve the equation for the indicated variable. Okay, so let me write out the quadratic formula one more time. And this time we're solving for t, so it's going to be t equals negative b plus or minus b squared minus 4ac all over 2a. And then we got this mess over here, so let's figure out what our a's, b's, and c's are. So I think our squared term's right there and it's negative, which I don't really love. So I'm going to move everything to this side and get it equal to 0. So I'm adding this whole term over, so that's going to make that 1/2 gt squared. And then I would be subtracting vt on both sides. And then that would be plus s would equal 0. So I just added this term and subtracted that term, and that got me to here. And so then that lets me see a little bit better what my a, b, and c are. So right there, that's a. Negative v is b, and s would be c. So it gets that all tossed in here. So we'd have t equals the negative of negative v, so that would be v, plus or minus negative v quantity squared minus 4 times a is 1/2 g, and c is s. All over 2a, so that's 2 times 1/2 g. And then this is a little messy, so let's get that cleaned up a bit. So then t equals v plus or minus v squared. And then right here, check it out. So 4 over 2, that's just going to be 2gs. And then half of 2, so then that's all over g, and that's it. That's as far as you can go.